Section 3.3.
Logarithms.
All right, so the deal with logarithms is when we talk about inverse functions and we have this exponential function y equals to the x, inverse functions means you switch the x and the y around. And so you do that and you go, oh no, how do I solve that for y?
I need it to say y equals K, Steve.
Yeah, how do I get that to be y equals?
It's right next to it.
Oh, we write it as a logarithm instead. So that's exactly what logarithms are. They are inverse functions for exponential things.
Is that a rebel insignia on your Band-Aid there?
Angry Birds Star Wars from my paper cut earlier today. So
good move.
So what happens whenever you rewrite this as a logarithm is this is our base, right? And we've talked about that.
So it's a log of base 2.
Yeah, this is where our base goes. It's the little number. And then it's like you go in a circle. You don't go to the exponent next. You go over here and you write x. So log base 2 of x equals y.
Yeah. Here's another way to think of it. A logarithm equals its exponent.
Right. So
what's the exponent here? Y. So a log has to equal y.
The exponent. And then
it has to have a base of 2, which just leaves one other place for that x.
Right.
There you go.
So what are we supposed to be doing on this example?
You want to graph out a little logarithm action there?
So do we want to graph both of these and check out the fact that they're inverses?
Sure.
Okay,
that sounds fabulous.
If we plug in 0 here, we get 1.
You get 1. And it's exponential, so it shoots up on the right and gets really close but never crosses the x-axis on the left. You know, if you walk from where we're currently sitting...
You said that in an earlier video.
You don't know what I'm going to say.
Okay.
If you walk from where we're currently sitting and do 2 to the x, by the time you get to that wall over there, you'll be way up in space.
That's great. That's so great.
Just like that movie Gravity.
Yeah?
They were up in space.
Yeah, they were. So log base 2 of x. How do we go about thinking about this? Like if we were to try to do it without our calculator and we plugged in values.
Ugh.
Don't say
Oh, sorry.
like
what
that.
I meant to say was, no problem. No problem,
So,
Mrs. K. Steve.
Log base 2 of 0.
No deal.
Because 2 to, there's no power.
2 to what power equals 0? And it ain't happening.
Right, so this is undefined.
Yeah, undefined. And if you'll notice on the graph that we just drew, it never actually crosses the x-axis.
Right. So what we're doing is since these are inverses, then we should have a reflection over the line y equals x.
That's
okay.
Pretty close.
It's okay.
Pretty close.
All right, so if we were to plug in 1, then we'd be saying 2 to what power is 1?
0.
Okay, so 1, 0.
Yeah, I like it.
And the other way to go is if we'd made a table of values for this one, we could just flip the x and the y. That would have been handy.
That would have been really handy, but we didn't do it, and that's okay. We're all good here.
If we plug in 2, 2 to what power is 2?
The first power. 2 to the first power is 2.
Okay, and then hopefully you can get an idea because these are supposed to be reflected that this should go this direction.
Yes, yep.
And this should
go... Now, as fast as an exponential equation grows, a logarithmic equation grows just that slowly. So we could actually look at a log base 2 of 1,000 and get a y value of like 10 or something like that.
Right.
Like that's not out of the question.
Right. That's true. So we have this note here that a common logarithm is a logarithm with a base of 10. When we have a base of 10 here, sometimes we don't actually write the base.
Most times, actually.
Yeah, so if you see log without a base, there is a secret 10 here. And then natural logarithms, which is ln.
Logarithmic and natural.
Yeah, it
sounds French.
Something like that. Those are actually a log with a base of e. Like those two together, log of base of e, make a natural log. So,
and it's called a natural log because, believe it or not, those numbers and ratios show up a lot in nature.
Go figure.
Yeah, it's amazing.
Yeah.